10.7 Areas of circles and sectors. The objective in this lesson is to find the area of circles, sectors, and segments of those circles. So if you remember, we find the area by the radius. And then we are going to use a fraction of that area to find sectors. And then you'll see how we do segments. So our first theorem here is one that we are very familiar with, the area of a circle. And you know that the area of a circle is pi r squared. And the only thing we really need to know about this, radius is diameter divided by 2. Circles are defined by their radius, so are identified by their radius. So we need the radius. If you're given a diameter, you just cut it in half. Let's look at our first problem here. The circular region, we want to know the area of the circular region of our wrestling mat. We know that the diameter is 32 feet here. So that means our radius is 32 divided by 2, which is 16 feet. And then we just write our formula. Area is pi r squared. We put our radius in there and square that, and we get our area is 256 pi feet squared. That's in terms of pi. Or we can round to the nearest tenth. That's 804 that would round up to 3 feet squared. So we just put it in our calculator. So that's easy enough. And wow, it is already your turn. Go ahead and pause the video and do that first problem. Those problems were super easy. Our first one was the area of the wrestling region if it had a 42-foot diameter. So that means our radius is 21 feet. Area is pi r squared. 21 squared. That would give us 441 pi feet squared, and we put that into our calculator to get a round to the nearest tenth is 1,385.4 feet squared. So area of a circle, easy enough. Next question said if the radius is halved, how does that change the area? Well, we know that area is pi r squared. So if we're going to half it, we have to square that. That would be, it's going to be 1/4. If you half the radius, it's 1/4 of the area. And again, that's because area is squared. So if we look at an example here, if we have a radius of 10, that would give us an area of 100 pi, whereas half that radius, a radius of 5, would give us an area of 25 pi. That's 1/4 as much. And we've seen this before in our ratios because area is squared. Okay, well, let's see what this is going to do for us. That was the easy introduction stuff. Our first thing here is the sector of a circle is the region that is bounded by an arc of the circle and the 2 radii that go with the endpoints. So here's our arc and here's our radii that go to those endpoints of that arc. This is a sector. And we name our sector using an endpoint, the center of the circle, and the other endpoint. So you see sector RPS here. There's no fancy symbol for it. We just name it sector RPS. It could also be sector SPR. Now, if you're looking at this and thinking, hey, this looks like what we did with arc measure and arc length, it's very similar. This is a fraction of the area. This is just a piece of pizza. You have the entire pizza, which is your area, and one slice is a fraction of that entire pizza. So that brings us to our next theorem, the area of a sector. And the area of a sector is our fraction times the whole area. So that's this right here. And you see right here, the measure of our arc over 360, this is what gives us our fraction, right? So the measure of the arc, don't forget that's in degrees, so we're going to find the measure of that central angle, and that's our arc measure. And then this is just times the area of a circle, pi r squared. So let's see how this works. Find the area of sector GPH. So there's G, there's P, and there's H. So we're looking at this right here, this slice of pizza. That's our sector in terms of pi. Okay, so what do we need to know about this? We need to know that our radius is 15 centimeters, and the measure of arc GH is 72 degrees. And so we just fill in our formula here. The measure of arc GH is 72 over 360, and we want this as a fraction over 360. I know those are both divisible by 9, so that would be 8 over 40. Oh, we can divide again. Divide by 8, and that's 1 over 5. So this is 1 over 5 times 15 squared. So I don't have a lot of space there. Let's see. So 1 over 5. What's 15 squared? 225. You should know that one. Put it over 1. Everybody's a fraction. And just times pi out there on the end. And 225 divided by 5 is 45 pi centimeters squared. And if we wanted it to the nearest tenth, we would just put it into our calculator. And that means it's your turn. We are just moving right through these. Go ahead and pause the video and do the next problem. If you followed the steps and wrote everything out, that was a pretty straightforward problem. We were told that our radius was 4 inches and the measure of our arc was 45 degrees. So I wrote my formula. The area of a sector is the measure of the arc over 360 times pi r squared. Put in my 45 and my 4. And then I am going to reduce my fraction here, 45 over 360. I know those are both divisible by 9, gave me 5 over 40. Those are both divisible by 5. And I got 1 over 8. So I could have divided both of them by 45, but I couldn't do that in my head right off the top of my head. So, because I know they both relate to 90. So they could both be divisible by 45. Anyway, you can divide as many times as you need to. I got 1 over 8. 4 squared is 16 times pi. 16 divided by 8 is just 2. 2 pi inches squared. And that's in terms of pi. If we wanted to, we could put that in our calculator. And 2 times 3.14 is 6.28, so 6.3 inches squared if we wanted a decimal. But we were asked for in terms of pi. All right. That's easy enough. That's not the hard part. Let's move on here. The part of a circle that is bounded by an arc and the segment joining its endpoints is called the segment of a circle. So we have our arc, and here's our endpoints of our arc, and here's the segment joining them. Later on we'll learn that's called a chord, but we don't need that right now. So this is the segment of a circle, and I like to think of that as the pizza crust. Okay, now how are we going to find the area of that segment? Well, this is why I like to think of it as the pizza crust, because to do that, we take our sector, which is our slice of pizza here, right? The area of the sector is the measure of your minor arc divided by 360 times area. And what we're going to do is we are going to subtract off the area of this triangle that we don't want. So we have our entire slice of pizza, and then we eat the pizza part, and you know area of a triangle is just 1/2 base times height. And all of that is going to result in having just the segment, just our pizza crust, left over. So the area of a segment is the area of the sector minus the area of the triangle. So let's look and see how this works. We want to know the area of our little segment here. So we need to have the area of the sector. What do we know about our sector? We know that we have a radius of 18 inches and the measure of arc AB is 60 degrees. And so we can just put that in. 60 over 360 is 1/6 times 18 squared is 324 over 1 times pi, and we end up with 54 pi. That's the easy one. How do we do our triangle? How are we going to find the area of the triangle? Well, there's a couple of ways we can do this. One thing that we do know is that these are always going to be isosceles triangles, because radii are always congruent, and I think that it happens in about chapter 12 when we do circles that we actually get that theorem. All radii are congruent, but I'll give it to you now for free. So let's look at this triangle here. We're going to draw it a little bigger than they have it. And because it's an isosceles triangle, okay, we know that this is 18 inches. Because it's an isosceles triangle, we can drop this altitude down, and we know that it bisects the angle, it's perpendicular to the base, and it bisects the base. So that is some fancy stuff there. We know that this entire angle here is 60 degrees. So what does this angle measure? You're right, 30 degrees, which means I have a special right triangle, a 30, 60, 90 right triangle, which means we have x, 2x, and x square root 3. So 2x equals 18. Divide by 2, x is 9. So this is 9 inches. This is 9 square root 3 inches. And this is half of the side, so the entire side is 18 inches. So I now know that for my triangle, my base is 18 inches and my height is 9 square root 3 inches. You see how we got that? You'll get special right triangles if the measure of your central angle equals 120, 60, or 90. Right? Because half of that is going to be 60, 30, or 45. We've got the two options to get our 30, 60, 90, and our one option to get a 45, 45. So anytime your central angle is 120, 60, or 90, you know you've got a special right triangle. And what if it wasn't? What would you do? Do you remember our area of a triangle using trig? If you have side angle side, isn't that what we have? Side angle side. 1/2 BC sine A. So if it's not one of these, you can use trig. So we'll put that in here too. Other trig. Sine angle A. All right, back to our problem here. So we know the base of our triangle is 18 inches. The height of our triangle is 9 square root 3. We plug that in. There's the area of our triangle. Well, what do we do with that? We know that the area of the segment, our pizza crust, right, is the area of our sector, that's our entire piece of pizza, minus the area of the triangle. So we eat the bottom of the pizza off and leave the crust. And look what we have here. 54 pi minus 81 square root 3. Those are not like terms. We are going to leave these problems in terms of pi and simplest radical form. So we would just put the answer of 54 pi minus 81 square root 3, and our unit is inches squared. Or we can always put it all into our calculator, and your calculator knows how to deal with this. You just put in 54 pi minus 81 square root 3, enter, and we would get 29 point, that rounds up, so 29.4 inches squared. So this is the area of our segment, our nice little pizza crust. Both of those are the same answer. And we are here at the end. It's your turn. Do the last problem. Well, that took a little bit of work, but it wasn't too bad. We wanted to know the area of the shaded segment here. So what do we need to know about this? We know our radius is 4 meters and the measure of our arc, PR, is 90 degrees. That's going to let us find the area of our sector, which is the measure of our arc over 360 times our area. So I put in 90 over 360, and our radius is 4, so that's squared. 90 over 360 is 1 over 4, 1/4. 4 squared is 16. That gives us 4 pi meters squared. And then I need to find the area of my triangle. So the area of my triangle is 1/2 base times height. Well, I redrew my triangle, and I noticed that it's a 90-degree angle, which means I already have a base and a height. Now, we could have, and these are just my radii, right? My radii are congruent. So I have a base and a height. They're both 4 meters. So I put it into my formula. Now, we could have drawn our triangle, drop this down, right? 45, 45. And we know that this is 4. And we could do x, and x square root 2. And we would come out with exactly the same answer. This would give us x equals divide by square root 2, and then times everybody by square root 2. We would get 4 square root 2 over 2, so we would get 2 square root 2. And then the entire bottom here would be 2 times that. So this would be 4 square root 2. And we would get 1/2. This is 2 square root 2 here. 1/2. Our base would be 4 square root 2. Our height would be 2 square root 2. And square root 2 and square root 2 just comes out to be 2. And so we would get exactly the same thing. So anytime you see a right triangle, remember, you already have a base and a height. So we could go up here and erase that. It's not even special. This one is already, I'm using green, you already have a base and a height if it's 90 degrees. So 120 and 60 are special, and 90 degrees is base and height. Anyway, let's get back to our thing here. So we have our sector and our triangle, and now we can find the area of our segment. Area of our segment, our little pizza crust, is just area of the sector minus area of the triangle. So that's just 4 pi minus 8 if we wanted it in terms of pi and possibly simplest radical form. Or we throw it all into our calculator and get 4.6 meters squared. Either way, same answer. Be able to do both of those. These problems, piece by piece, will make it a lot easier. Okay? Label what you know, do each section, and I know you will do fabulously. So have fun on your homework. Enjoy your introduction to circles. And don't forget to do your video quiz.